In this example, we are looking to do d squared y divided by dx squared, which really just means second derivative. And so that is what we're looking to find. So we're looking to take the second derivative of this, and this is the equation of a circle. We got to do the derivative and then do the derivative of the derivative. So let's just start. So derivative of this circle is x squared plus y squared equals 1. So if we do the derivative of x squared, we're going to get a 2x plus the derivative of y squared is 2y dy dx. And then the derivative of 1 is 0. All right, so in order to do the second derivative, we need to get dy dx by itself. Okay, so we're going to look to solve for dy dx at this point. All right, so we're going to subtract the 2x over, so we would have a 2y dy dx equaling negative 2x, and then we'll divide by 2y, and then that's going to get us dy dx equaling, we'll simplify the 2, so a negative x over y. Great. All right, so halfway there. So now we're going to end up doing the derivative of this because we're doing the second derivative. So we're going to be doing the derivative with respect to x of dy dx equaling negative x over y. So when we do this first part, this is how we get our d squared y over dx squared, right? That's where that symbol is going to come from. And then on the other side, we have a quotient rule. So we have top, bottom. So we're going to be doing the whole full-on thing. So if we're going to do the quotient rule, we're doing the derivative of the top. So the derivative of negative x is negative 1 times the bottom minus the top times the derivative of the bottom, which is 1 dy dx over the bottom squared. Okay, so here's where it gets a little tricky. That here is our still d squared dy dx squared. So if we clean this up a little bit, we got a negative y plus an x dy dx over a y squared. So it's not uncommon to have this piece, but this isn't finished. Like our answer should be, the second derivative should just be x's and y's. So how do we take this dy dx? Well, we have a value for that. So this negative xy gets subbed in for dy dx. So here's where it's going to take some algebra. So we have a negative y plus x times negative x over y divided by y squared. All right, so to clean this up, let's keep on pushing. So let's put this together, and we are looking at a, should have wrote it here, d squared y over dx squared, d squared y over dx squared, and then we have a negative y plus, we'll put that over 1, actually a minus, because of our sign here, minus x squared over y squared. All right, so we have this fraction within a fraction. And there's one nice step that'll kind of clean this whole thing up. And it's all about what our common denominator is. We don't have any other denominators other than y. So we're going to take every single piece and multiply it by y. So we're distributing a y to the top, we're distributing a y to the bottom. And it has one goal in mind, and that is to clear out this fraction. So whether it needs the y or not, we're multiplying it because it does one thing, that it gets rid of our fraction within a fraction. But what it does do is kind of bumps everything else up a little bit, but that was going to be unavoidable. So we're going to have a negative y squared minus x squared over y cubed. Right? So that feels like we're done, and a lot of times it is, but strangely, we could go and make this a little simpler. And sometimes you'll see this and sometimes you won't. This, we could be done, but let me show you how you could actually manipulate this a little bit better to even a simpler answer than this. It's this right here. If you take this equation of x squared plus y squared equaling 1, and if you change the signs and make it a negative x squared minus a y squared, it would be then equal to negative 1, because that really is kind of just a derivative or a manipulation of what we originally started with. We can take this whole thing and we can actually d squared y squared, d squared y, we can actually rewrite it as this whole numerator can become a negative 1 over our y cubed. Right? Because we know that that equation is constantly going to equal 1. Well, if I change the signs, then it's going to constantly equal negative 1. So no matter what x's and y's you plug in, they should turn into a negative 1, right? As long as they satisfy this original thing. So if they satisfy that, x's and y's, certain x's, certain y's are going to combine to make a 1. That also means certain x's, certain y's are going to combine to make a negative 1. So that's way simpler, but it may or may not ask for something like that. But every once in a while, you get this extra little layer of simplification that you might be able to do. Right, and that was doing a second derivative.